In this video, I'm hoping to give you what I would think is a reminder of linear regression. So we have been given some data. I took this from the book. That's why I say we've been given. We've been given some data that represents different months of the year and the sales that have occurred in those months. With most data, the first thing you want to do is draw a picture. So that's why I've highlighted the data. I'm going to go to the Insert tab and the XY. I want the scatter plots. And I'll just put the points in. Okay, well, when I look at this picture, some things that I notice, it's a little bit wavy. But if I were estimating, which means I don't have to have perfection, I would estimate some sort of line, perhaps, that was upward sloping, that passes through these points. Now, what kind of line do I want to pick? If you think about the notes for this particular module, one of the things we say about the trend line is that I'm going to try to find a line, making a line that has slope B and intercept A, and that line will pass through these points. And what I want it to do is I want it to minimize the error when it passes through those points, where error is going to be defined either as in the notes or as the distance between what actually happened, which is the dot here, each of these dots is what actually happened, versus what we would forecast if we were to use a line to forecast the demand for this product. So first things first then, showing a line, we have time on the horizontal axis and total sales on the vertical axis. All right, what work do we have to do? Well, in the textbook, or maybe, probably in the textbook, we've got these estimates. So, for example, I want to find a line whose slope and intercept will create a line that passes through all these points, and we'll do it in such a way that it minimizes the error. Well, going through the process of minimization of the error squared, we come up with these estimates or these values for A and B that will give me a line that will do just exactly what I want that to be shown. Okay, later I'll show it. So, well, what is all of this? Well, we've got to make sense of what the notation means. What this says to do is it says for me to add up the product of each time period and each value of y. So 1 times 6120 plus 2 times 6920 plus 3 times 6840, and I just keep that process going until finally I finish with 20 times 11770. I add all that up, I multiply by n. Or as set up here, I put it here, and I'll show you how to do this in just a minute, how to get that number. All right, then it says, this next one just says, well, add up all the time. Oh, okay, well, I'll just sum that column of months. And this, I'm summing up all the demand. Well, all the demand is this column B. And then n times the sum of times squared. So, in other words, we walk through this process that's been dictated to us through an optimization problem. So let me show you how Excel gets us through each of these summations. All right, first things first, I need to know how many data set points are in this data set. So what I've used is the function count, and then I have covered the data points that I want counted. So why use count, right? If I'm counting time, why not just put the 20 in there? Well, because linear regression is not always that nice to you, meaning those time periods are not one increment after another all the way up through 20. So I gave you a function that's general, and it will work in any circumstance. All right, here what I need is n, so what we calculated up here, times the sum of the product of the t's and the y's. All right, well, fortunately for us, Excel has a function called sum product. And what it asks for is the sum product of time, that column where all the time is, comma, and then the column where all the sales records are. So notice I've highlighted all of the data by the time I'm done. And then I'm multiplying that by n, which lives up here in G1. Then I need to sum up all of the time. Now we should know this one. This is just the word sum. So isn't that nice? I mean, sum of the products is sum product, and just the sum is the sum. So I sum up all of the time periods, 1 through 20. And then I need to sum up the entire demand, or all of demand. So I use that sum again. Okay. Well, now I'm down in the denominator of B. And in the denominator of B, I need the sum of the time periods squared. Well, look at that. Excel has a sum squared. So I can highlight the column that I want to take the sum of the squares of, and I can say, okay, take the sum squared of that column and multiply it by n. And finally, I need the sum of the t's, sum of the time periods squared. Well, I took the sum of the time periods up here, so this is really just this 210 squared. Okay. Now, we should have enough to go ahead and calculate B. So B is equal to n times the sum of t times y. So notice I've used a parentheses so that I can group. I want that numerator to evaluate and the denominator to evaluate, and then the division to occur. I don't want to be having, that's how I want it to go. So I want to make sure I do this measurement right. All right, so I just go through the steps and I say, okay, I need this n times the sum of t times y minus the sum of the t's times the sum of the y's. That should give me my numerator. In the denominator, I need n times the sum of the t's squared, that's in G12, and I need the sum of the t's squared, which is in G16. And that gives me a value for B. Now, I have to do B first, because in order for me to get A done, I need to have B. I need the sum of the y's. So the sum of the y's are here in G9, minus B times t, the sum of the t's. So I got B times, so there's B, what we already calculated, times the sum of t's, which is up here in G6. And then I need to divide, once I've done that work, notice the parentheses, then I'm going to divide by the number of observations. Now just a note, first off, these equations are not the only equations, it's not the only way to write these equations, let me say it that way. We could mess around with the algebra and we could do a lot more with these equations than we've done right here. In fact, we could make them more intuitive. For example, B is actually, and even though you don't see it this way, is actually the covariance. So here's what I could do. It's equal to the covariance between between T and sales divided by the variance of the X values, which are months or time. And yes, you see that I did get the exact same answer. So there is some intuitive meaning to all of this graffiti here on the page. One other thing you might ask, is there a simpler way to get the slope and the intercept than going through this process? And I always hesitate to give simpler versions because I like people to understand why they're doing what they're doing. Because if you understand what it is you're doing, you can also understand when you've made mistakes. But let me just show you. Excel has this slope function. It says if I have known y's, okay, that would be my sales. And then it says next thing I need are the known x's, that would be my months, that I could calculate the slope that way. Because notice again I've got the same answer. And it also has an intercept function where I go in and I put in the known y's, comma, known x's, close parenthesis. And notice that function gives me the intercept term. Okay? Well, once I have these functions, once I have this information calculated, then what do I do next? Right, well, my next job is to actually do the forecasting. So let's think for that 6,034.53 and a slope of 263.9. So it looks like, I mean, if you read what this says, every time period I would forecast my sales increasing by 263.9 units, or essentially 264 units. So that's my forecast. All right, well, I could go make estimates. Now I'm going to make estimates in a couple of different time periods. I'm going to make a forecast within the data that we already have. That doesn't seem like much of a forecast, but as we'll see later, it's how we calculate or estimate errors so that we can monitor or we can alter our forecast equation. So I'm going to do a forecast within the data. So I need to just use my equation given here, and that would be 6,034.53 plus 263.9 times 1. And so I get that first number. Second number, 6,034.53 plus 263.9 times 2. And I just keep working that process all the way down through the data. Okay. Now the actual forecast outside the data is done the same way. It's done as the slope plus the intercept plus the slope times 21, the intercept plus the slope times 22. Now, if I want to compare, in this picture I can do some comparisons. My forecast is this orange or rust looking line, and the blue dots are the actual measurements. So my forecast is not too bad. Remember, the distance vertically between each dot is the error that occurred in that time period. Also note that I have 2 data points out here outside the time period, so I am doing a forecast outside of my data set, and eventually we'll have to talk about, well, how good is that forecast? Well, hopefully this gives you a quick overview or a reminder of how to calculating regression lines. So this is going to help give you an estimate, or this shows you the process for estimating this regression equation, using these as a direction so that you can get an A and a B as slope and an intercept that will minimize those vertical distances between the actual points in blue and the estimated points in orange. So, thank you.